Confidence intervals for the mean. Our second video will feature something called a t-distribution, okay? T-distribution we will use when the standard deviation is unknown and the sample size is smaller than 30, okay? So with it being less than, I kind of joke from time to time that t is tiny. T and tiny, okay? The confidence interval for the mean that we did previously had a sample size greater than or equal to 30. So now we're small or tiny. Okay, there are some characteristics of the t-distribution, such as it is bell-shaped, it is symmetrical, mean, median, mode are 0 and located at the center. The curve never touches the x-axis. That sounds very similar to, you got it, the standard normal curve. From there, a few extras that I added in here. The variance is greater than 1. The t-distribution results from a family of curves based on degrees of freedom. The degrees of freedom, I just put DF for degrees of freedom, tells which curve to use because it's a family of curves. And also we know that as the sample size increases, the t-distribution approaches the standard normal. So the closer we get up towards 30, the more it resembles our standard normal curve. All right, so from there, you can stop the video and update your notes as needed. I'm going to keep going so your video isn't quite so long, okay? All right, so degrees of freedom, or DF, okay? The number of values that are free to vary after a sample statistic has been computed and tells the researcher which specific curve to use when a distribution consists of a family of curves. Degrees of freedom is always equal to n minus 1. Okay, so let's do an example. It says the mean of 5 values is 10. What is the degrees of freedom? Okay, well, mean of 5 values. So that means your n is 5. So when you do degrees of freedom, you're just going to do 5 minus 1, which is 4. Okay? So it means that you have 4 values are free to vary. In other words, they can be whatever they want to be. But the 5th value is specific so that, or to get a sum of 50. Okay, so where did I get 50 from? Well, if you think about it, the mean of 5 values, okay, so I have 5 values. I'm just going to call them x sub 1, 2, 3, 4, 5. Okay, so whatever they are. Okay, if I divide by 5, I take the average, and I get 10. Okay, so the idea is that these 4 could do whatever they want, number. But once they do whatever they're going to do, that 5th guy's locked in. Okay, so 4 can go out and run around town, but the 5th one has to do something specific so that our average works out. Okay, that's degrees of freedom. Okay, all right, so next up, let's go on down the page here a little bit. Formula for confidence interval of the mean, this time tiny or t distribution. Okay, so this again you'll want to put to your formula sheet. Okay, includes the idea of degrees of freedom. Okay, so let's take a look and see what's going on here. So it says find t alpha over 2 value for a 95% confidence interval. Whoops, sorry. Get this guy out of here maybe. Or not. We may just turn it around, or we may just deal with that down there, which I did this the other day accidentally, and I am sorry, but I really don't know how to get rid of that off the video. Ah, voila, there we go. All right, so find t alpha over 2 for a 95% confidence interval when the sample size is 22. Okay, so if you're using a t-table, okay, We would go look at that table. In our book, it's on page 784. Okay, or I'm sure if you Google it, you'll find a T table. But basically, if you can tell me the degrees of freedom is going to be 22 minus 1. So 21 is our degrees of freedom. Okay, our N is 22. Our alpha, okay, remember it's the sum of both tails. So if I'm 95% confident, alpha is 0.05. That means alpha over 2 is 0.025. So if you go look in a table, T alpha over 2 is going to be 2.080. Okay? And again, I'm showing you these. We're not going to do tons with it right now just because of our given situation. Okay? But let's do another one. Okay, the next one, 99% confident, sample size 14. Okay, so N is 14. That means your degrees of freedom is 14 minus 1, or 13. Alpha this time, if we're 99% confident, is 0.01. Okay, so that's the total in the tail. Alpha over 2 is for one tail. So 0.01 divided by 2 is 0.005. Okay, so remember, that's for one tail. Okay, so then if you were to use a table, T alpha over 2, 3.012, and again, that's from the table. No table, you wouldn't be able to look that up and tell me that information. Okay. All right, let's try a full example and put this formula to work. 10 randomly selected automobiles were stopped and the tread depth of the right front tire was measured. The mean was 0.32 and the standard deviation was 0.08. Find the 95% confidence interval of the mean depth. Assume the variable is normal. All right, so here we go. N, we need to figure out what N is. Okay, well, from that first sentence, N is 10. The mean, okay, the mean, 0.32. All right, we have a standard deviation. Standard deviation, 0.08. Okay, and we wish to have a confidence interval of 95%. So that tells you some stuff like alpha is 0.05 and alpha over 2, 0.025. Okay, so if we work through here, okay, we want to do filling in the formula. The mean is 0.32 minus, now this T alpha over 2 level by hand, we would have to look that up on the chart, and you get 2.262. Hopefully I can talk to you a little more about that in class so you can find that easier. So 2.262 times 0.08 over the square root of 10. Okay, so I'm just filling in the formula up here at the top. Okay, and then that's less than, the mean is less than, and I'm sorry I got going here too far down, go this way. Same sentence with plus sign. So 0.32 plus 2.262, 0.08 over the square root of 10. So if you do your calculation, it's 0.26 is less than the mean, is less than 0.38. That would be the confidence interval of the mean, such that you could say with 95% confidence, the population mu is between 0.26 and 0.38. Okay, and I don't know why I put those in parentheses, I just did. Okay, all right, last thing to mention, if you're at home and you're not where you understand this table, you can also try to do your confidence intervals this way. If you push the button on your grapher, TI-84, 83, stat, tests, choice number 8 should be T interval. Okay, and if you enter the parts in the correct places, following the definitions and the notes I've gone over with you, you should be able to calculate this t-interval. Okay, hopefully we can talk about that a little further either on a Zoom or in class at some point. Okay, so again, what to do: you should take this note, add this formula to your formula sheet. Probably want this degrees of freedom in there as well. Okay, and I look forward to talking to you soon. Good luck with your t-intervals. Bye-bye.